In this session, let us construct a DFA for accepting binary values divisible by 4 over the symbol set 0, 1. Now, binary values divisible by 4 is also equivalent to any given value mod 4 is equal to 0. That is also true. So, if I supply 100 mod 4, 100 is 8. So 8 is completely divided by 4. It gives me 0 remainder. Similarly, 12, 16 and so on. Now let us design or construct a DFA for the same given problem statement. Now see, problems like this, whenever maybe mod divisible by 4 or divisible by 3, whatever. So we are supposed to follow one methodology, that is make these things binary values into state, okay, plus input symbol. Now I will come back to this. Now since we are designing DFA for binary values divisible by 4, first we have to decide on the states, how many states we do require. Now since it is divisible by 4, we require 4 states, starting with Q0 as initial state, Q1 as one normal state, Q2 as another state, and Q3 is also normal state. So since we are putting a solution for completely divided by 4, that means remainder is 0, so 0th state becomes final state. That means in this DFA, Q0 is acting as initial state as well as final state. Now, see, now the DFA is in Q0 state, initial state. What if it receives a 0? What if it receives a 0? I directly wrote this, but let me check here. So we require 2 binary digits, that is 0 and 1. So their count is 2. Now the DFA is in state 0, 0th state, okay? And the input symbol is 0. So what it gives? 2 into 0 is 0, 0 plus 0 is 0. It reaches to, write like this, okay. It reaches to which state? State is 0. That means it stays back on the same state. One more. What if the DFA on this state takes a 1? Takes a 1. Now it is, once again, 2 digits, 2 into, now it is in 0th state, okay, and it takes a 1, this gives rise to 2 into 0 is 0, 0 plus 1 is 1, that is 1. That means it moves to first state, state number 1, that is Q1. Now that Q0 has dealt with 0 as well as 1, Q0 job is over. Now let us move on to Q1. Now on Q1 state, what if it reads a 0, that is 2 into 1 plus 0. This gives rise to 2 into 1, 2, 2 plus 0 is 2, it goes to Q2 upon 0. What if it reads 1 on this state? It is plus 1, that is 2 into 1, 2 plus 1, 3. It goes to Q3. Okay? So now that it has read both 0 and 1, okay? So let us leave Q1, let us take upon Q2. Now what if on this state it reads a 0? Okay, that is 2 into 2, 4, 4 plus 0 is 4, but we don't have a state I labeled 4, because if 4 is the value we have to show upon, it is nothing but, since the values are divisible by 4, it goes back to 0, that is 0th state. That is, you just make 4 mod 4. Here also, if you make 4 mod 4, 3 mod 4, you get 3. 2 mod 4, you get 2. 1 mod 4, you get 1. Similar thing. Okay, I hope you understand. Next, what if from this state, in this state, DFA reads 1. So it is 2 into 2 plus 1, which is equal to 4 plus 1, 5. What is 5 mod 4? It's 1. So it goes back to 1. Now Q2 has dealt with 0 as well as 1. Let us not touch upon, let us move further. Now we are in Q3, okay. Here if it reads 0, it goes to 2 into 3, 6, 6 plus 0, 6, 6 mod 4 is 2. So, yeah. Okay. And what if it reads 1? That is 2 into 3, 6, 6 plus 1, 7, 7 mod 4 is 3. It stays in the same state. Okay, now see, Q0 has read 0, 1, Q1 has read 0, 1, Q2 has read 0, 1, Q3 has read 0, 1. Now that our DFA solution, or the problem statement has completed, now let us cross verify. Okay, let us verify it for one of the values, that is, let me take 1, 0, 0, which is equal to 8. So earlier I told 1, 0, 0 as 8, it's not 8, it is 4. Okay, that is also divisible. Please correct it. Now, 1, 0, 0, 8 mod 4 is 0, we know this. Let us see here what happens. Now, let us start from the starting state. Okay. So 1, upon reading 1, it goes to Q1. Upon reading 1, it goes to Q3. Okay. Upon reading 0, it goes to Q2. Upon reading 0, it goes to Q0. So Q0 is the final state. That means this string is accepted. See, whenever the DFA completes its operation in the sense, it reads all the string, all the symbols. Okay. If it is accepted, then DFA should be in final state. It should not be in any of the normal state. Let us take one more string. Okay. Let us take 1100. Let us take. So 1100 is 12, and 12 mod 4 is 0. We know that. Now let us see here. Okay, that is 1, 1, 0, 0. So accepting state. So valid DFA. So let us take one more example. That is 1111, which is nothing but 15, and 15 mod 4 is not equal to 0, which is equal to 3. Okay, so it should land on Q3. Now let's read the symbols taking the DFA into consideration. Now 1, from the initial state on 1 Q0, it goes to Q1, then from Q1 it goes to Q3, from Q3 it remains in Q3, and one more one it remains in Q3. So Q3 is not a final state, hence this string is not accepted. So I hope you are able to understand now with respect to different scenarios, valid string and invalid string. Okay, thank you.